Right now, three-dimensional assets are rapidly saturating every major industry. E-commerce retailers rely on 3D models to showcase specific clothing lines, while the energy sector builds massive digital twins for equipment inspection and safety training. The tools used to create these 3D models have become highly advanced, yet the infrastructure most enterprises use to manage, store, and share them is still built entirely for a flat two-dimensional world. This structural comparison highlights the problem. On the left, a standard 2D image file is just a simple flat grid of pixels, but on the right, a 3D digital twin is a dense, multi-layered web containing spatial depth, complex geometry, and physics data. Treating these multi-dimensional assets like traditional text or image files creates a severe bottleneck. It actively halts an organization's ability to scale their workflows and deploy new spatial technologies. In practice, this structural mismatch creates a chaotic daily workflow. Teams are forced to juggle an alphabet soup of incompatible file formats. They have GLTF and OBJ files for standard web viewing, USDZ formats required for Apple devices, and point clouds, which are massive collections of raw spatial data generated by laser scans. This diagram illustrates a financial drain. A 3D asset is created, but sitting in an unorganized local drive, it's quickly lost. Teams must spend resources repurchasing duplicate assets. Even when found, massive 3D files choke standard networks and routinely crash web browsers. Without a specialized infrastructure layer to handle this weight, the gap between creating 3D content and actually utilizing it will only widen, locking valuable assets behind a wall of technical friction. To dismantle these bottlenecks, enterprises require a specialized pipeline. That is exactly what Echo 3D provides, beginning at the very first step, intelligent asset ingestion. The platform integrates an AI-powered multimodal search engine designed to instantly locate specific 3D assets hidden within massive, disorganized enterprise libraries. Multimodal simply means the system accepts multiple types of input. Users can track down a specific 3D model by typing a text prompt or by uploading a standard 2D photo of a visually similar item. As we see in this algorithm model, the AI scans the chaotic library, instantly isolates the matching asset, and then automatically generates tags and customizable metadata to index the file permanently. This intelligent discovery mechanism ends the cycle of duplicate asset repurchasing. A dead hard drive of lost files becomes an active, searchable library. Solving the search problem leaves the second major bottleneck, the immense file sizes that prevent spatial data from being easily shared or rendered. To solve this, Echo 3D applies proprietary 3D compression technology. This system systematically reduces the heavy data footprint of massive digital twins and detailed product models. The dense polygon mesh is mathematically optimized. Its internal data structure is simplified, while its exterior boundary remains intact. These optimized files bypass hardware limits, streaming in real time to devices with limited computing resources, like mobile phones and headsets, anywhere in the world. True spatial computing relies on lightweight, instantaneous streaming. This specific compression protocol finally makes that a reality. Beyond the files themselves, 3D management requires organizing the people working on them, coordinating team collaboration across decentralized organizations. To handle this, Echo 3D functions as a GitHub for 3D content. It utilizes robust version control, file locking, and real-time annotations, so global teams can iterate on a single asset without ever overwriting each other's work. Of course, collaborative tools are useless to major enterprises if they compromise internal data privacy. Flexible deployment options are a mandatory foundation. On this deployment architecture map, organizations can host libraries within Echo 3D's cloud, or maintain total internal control by deploying entirely on-premise, or within their own private Google Cloud, AWS, or Azure tenants. A collaborative platform only works for top-tier enterprises if the underlying data architecture is flawlessly secure and totally private. Contrast the sluggish, chaotic workflow of scattered local drives against Echo 3D's real-time analytics dashboard, where every asset's access point and performance metrics are instantly visible. The final result is a single, optimized 3D asset streaming effortlessly and simultaneously into a web browser, a VR headset, and a heavy game engine. This shift in architecture moves 3D management from a fragmented storage problem into a dynamic, cross-platform ecosystem. Ending file chaos accelerates the utilization of digital content. It removes the friction from the pipeline, freeing teams to focus on creating rather than searching for lost files. As enterprises scale their use of spatial computing and digital twins, the back-end infrastructure must keep pace to prevent a total data standstill. Join over 200,000 professionals and take control of your 3D assets today. Schedule a demo and start building your pipeline at echo3d.com.